Before we get to the experiment, we first have to explain what Charles' law and the ideal gas law is. First off, let's start with the explanation of Charles' law. Charles' law states
that at a constant pressure, the volume of a fixed amount of gas is directly proportional to its absolute temperature.
Now what does that mean? Where since it is directly proportional, the volume of the first substance will equal the temperature of the second substance, which shows a multiplicity relationship compared to the volume of the second substance times the temperature of the first substance, therefore making it directly proportional to its absolute temperature. Well, we know that at home when you take a shower, it really does suck to drop the soap, because when you do, it interacts with the water, sinks in, and then it's hard to grab because it's wet. However, do you think that if I put this ivory soap in this tub of water, will it sink or will it float?
Oh my god, it floats! So you see, all these air pockets interact with the molecule to make it float.
In 1890, an ivory soap factory worker was whipping up some soap. However, he whipped it up too long, causing a lot of air to be put into it. However, users loved it so much that they kept it that way ever since.
Step 1. Turn on the gas.
Step 2. Light up the gas.
Step 3. Get the water to boiling point. Remember, only have a small enough sample so that the water molecules in the soap will interact, and you can still see the maximum effect of the soap. So right now, the current temperature of the water is 35 degrees.
At boiling temperature, place the soap in the water.
So you see, the water and the soap molecules are interacting, and soon you'll see the effects of this.
As you can see, the bottom part of the soap is expanding.
Due to a little safety issues, the beaker in many cases got too hot. But however, you can see, as it quickly cooled, the soap returned to original non-expansive state. So you can see, that even though it was so hot, the glass almost broke instantly on contact with much less colder water. And you can see there that the soap went back to its original size. So we were able to still keep the flask at constant pressure, or beaker, I apologize. And you can see that the volume of the soap is a fixed amount of gas, or in this case, a fixed amount of solid of the air particles inside the soap, and it expanded in proportion, directly proportional to the absolute temperature.
The gas laws you have just learned, Boyle's law, Charles' law, and Avogadro's law, relate to one of the four gaseous variables to another variable. The equation PV equals nRT, called the ideal gas equation, describes the physical behavior of an ideal gas in terms of the pressure, volume, temperature, and the number of moles of gas. This equation shows that P is inversely proportional to V, while V is directly proportional to T, while V is directly proportional to N. The following demonstration will show how at constant temperature and increasing the temperature to get a reaction, the volume and the number of moles are directly proportional. Here are two different sized pieces of ivory soap, one small, one large. We will heat them up each for 2 minutes. First, we'll heat up the smaller piece. And now the second piece. Here is the result of the experiment. As you can see, the smaller piece only inflated to this size, while the larger piece inflated to this size. In the equation PV equals nRT, we can see that pressure and the temperature was constant. However, the variance in moles, number of moles, was also directly proportional to the volume of the soap.
Step 1. Turn on the gas. Step 2. Light it. Step 1. Turn on the gas.
Step 2, light up the gas.
Step 1, turn on the gas.
Step 2, light up the gas.